Hi guys, this is Miss Colson and today we are going to look at Lewis structures for ionic bonding. To draw a Lewis structure or an electron dot structure for an ionic compound, the nucleus and all of the inner energy levels are going to be represented by the chemical symbol from the periodic table, like C for carbon or Ca for calcium or N for nitrogen. We are simply going to draw valence electrons using a dot to represent each electron. So carbon has 4 valence electrons, so we draw 4 dots. Calcium has 2 valence electrons, so we draw 2 dots. And nitrogen has 5 valence electrons, so we draw 5 dots. Let's look. Group 1A has 1 valence electron. Group 2A has 2 valence electrons. Group 3A has 3 valence electrons. Group 4A has 4 valence electrons. So you might see here there is a trend with the number of the periodic table and the number of valence electrons. So group 5A would have 5, 6A 6, 7A 7, and group 8A has 8, with the exception of helium, which has 2. So how are we going to draw the electron dot structure? Anything in group 1A has 1 valence electron, so it's going to get 1 dot. The X here simply represents the element on the periodic table, any element in group 1A. Because group 2A has 2 valence electrons, it gets 2 dots. Group 3A gets 3 dots because it has 3 valence electrons. Group 4A gets 4 dots because it has 4 valence electrons. Group 5A is going to get 5 dots because it has 5 valence electrons. Notice at this point we now begin to double up our valence electrons. We draw them at the top, to the right, down at the bottom, and then to the left, and only once we start at 5 do we begin to double up. Group 6A is going to have 6 valence electrons. Notice we still have 2 unpaired electrons, one on the bottom, one on the left. 7A has 7 valence electrons, and group 8A is going to have 8 valence electrons, or 8 dots. So let's draw the electron dot structure for the following neutral elements. Potassium. In its neutral form, potassium is in group 1A, so it has 1 dot. We use K for potassium, the symbol K, and we put 1 dot. Bromine is in group 7A, so it's going to have 7 dots. We use Br to represent the nucleus and all the inner energy levels, and the dots simply represent the valence electrons. Gallium is in group 3A, so it has 3 valence electrons. Cations do not have dots showing valence electrons. They are only given the charge of the ion. So when we draw barium in its ion form, we don't have any dots because remember, a cation donates electrons. So barium donates both of its valence electrons, so it has no dots. Potassium has a +1 charge because it too has gotten rid of all of its valence electrons. Anions gain electrons. Because they gain electrons to fulfill the octet rule, an anion is going to have 8 dots plus its charge. So iodine has 8 dots and a -1 charge. Phosphorus has 8 dots and a -3 charge because phosphorus gained 3 valence electrons. All right, so let's look at these. How are we going to draw a Lewis structure if it is an ion? All right, so in number 1, we are going to simply put the charge +2 because number 1, the example number 1 is in group 2A, and it has 2 valence electrons which it has given away. In example 2, this is going to have a charge of +1, because it is in group 1A and it has donated one electron. So it's gotten rid of its valence electrons from the neutral form, and it has a charge of 1 plus 1. All right, in number 3, this example gains 3 valence electrons because it's in group 5A. So it originally had 5 valence electrons and it now gains 3. So we have 8 dots and a charge of -3. Our fourth example has a charge of -2 and again 8 dots because sulfur is in group 6A. It originally had 6 valence electrons and it gained 2. So what does this matter, and how do we make a Lewis structure for a neutral compound? We're going to start by drawing sodium and fluorine in their neutral form. Sodium has 1 valence electron. Fluorine has 7 valence electrons. Cations donate electrons and anions accept. So sodium is going to give its 1 electron to fluorine. So the red arrow, represents the movement of the valence electron in sodium over to fluorine. Sodium now has a +1 charge, and fluorine has 8 dots and a -1 charge. So if you think about it, sodium had 1, it gave it away. That's why we have no dots for cations. Fluorine started with 7, it gained 1, so it now has 8, and that's why we draw fluorine with 8 dots and a -1 charge. Calcium chloride. We have 1 atom of calcium and 2 atoms of chlorine. So calcium's in group 2A, it has 2 valence electrons. Each chlorine is in group 7A with 7 valence electrons. Calcium is going to donate 1 electron to the first chlorine and the second electron to the second chlorine. So calcium now has no dots and a charge of +2. Each chlorine now has 8 dots and a charge of -1. Let's try to draw these structures. Magnesium sulfide. We have 1 magnesium and 1 sulfur. We'd start by drawing the valence electrons. Magnesium has 2, sulfur has 6. Magnesium is going to donate both valence electrons to sulfur, leaving magnesium with a +2 charge, sulfur with 8 dots or 8 electrons and a -2 charge. Potassium oxide. We have 2 potassiums and 1 oxygen. Each potassium has 1 valence electron while oxygen has 6. So each potassium is going to donate its 1 valence electron to oxygen, leaving us with 2 potassium ions that each have a +1 charge, and an oxide ion with 8 dots and a -2 charge. Lithium nitride. Number 3. We have 3 lithiums and 1 nitrogen. Each lithium has 1 valence electron, while nitrogen has 5. So each of these 3 valence electrons from lithium is going to come over to the nitrogen. So each lithium donates 1 valence electron to nitrogen, and that leaves us with 3 lithium ions that have a +1 charge and a nitrogen ion called nitride that has 8 dots with a -3 charge.